Morning, everybody. We're going to look at the last two pages in your notes packet, solving exponential equations, and more exponential equations, but in the second one, we're not going to be able to find a common base. So if you'll get out the last two pages of your notes packet, I'm only going to work on the about half of this front side, and then a couple more on the front side of this, but that's where I'm going to stop, okay? So I don't want to get too deep into either of these topics, but definitely want to get some of it done over the next 2 digital days. So use the properties of exponents to simplify each side of the equation. So look at the left side, see what it needs to be done to simplify. Look at the right side, see how to simplify it. Then step 2, we got to make sure they have the same base. By base, I mean like the 2 here and the 2 here, the 5 here and the 5 here. Simplify means I've got to get this expression with one base. I can't have 2 bases on the same side. So I condense this using my exponent rules, and then I drop the bases once I have the same base. All right, so let's just jump into it. All right, so step 1 is done. I can't simplify either side here. Step 2 is done because I have the same base on both sides. So all I have to do is step 3, drop the bases and solve. Okay? So x plus 1 equals 9. It is that easy. Now it's going to get a little bit harder as we go down the page because they're not going to do steps 1 and 2 for us. Okay? Over here, steps 1 and 2 are already done, so I drop the base. The 4n plus 5 equals n minus 7. Subtract n from both sides. 3n plus 5 equals negative 7. Subtract 5 from both sides. 3n equals negative 12. Divide both sides by 3. N equals negative 4. Okay? Now, what does it mean by simplify each side? Well, we know from our rules of exponents, we may have forgotten, but we knew at one time that if we're multiplying like bases, we can add these exponents. So I'm going to actually write it like this: k plus 2, and then equals 3 to the 5k minus 1. Okay? So when we condense this, here's something to be careful of and watch for. A lot of people think when they condense this that they have to multiply the bases 3 times 3 and put 9 right here. No, no, no. When you multiply like bases, the base stays the same and you just add the exponents. So that's 3 to the 2k plus 2 equals 3 to the 5k minus 1. Now I can drop the bases. So my new equation is 2k plus 2 equals 5k minus 1. Subtract. I'm going to subtract 2k from both sides, even though I could have subtracted 5k from both sides. Just got to make sure I get the k's on one side and the constants on the other side. Now I got to add 1 to both sides. 3 equals 3k. Now divide both sides by 3. k equals 1. Okay. All right, so I'll skip 4. Let's come down to the second type of equation. Now, there is no common base here, but can I rewrite 36 differently? Can I rewrite 36 as 6 to the power of something? Well, yeah, 36 is 6 squared. So there we go. This number is the same as this number. So now I have a common base, and I can drop the base. 2x minus 10 equals 2. So then I add 10 to both sides. 2x equals 12. Divide both sides by what? If you were thinking 2, you're right. X equals 6. This one's tricky, but 1 over 7 is the same thing as 7 to the negative 1 power. Check it in your calculator. So I'm not going to finish this, but I'm going to drop the bases. 4x plus 11 equals negative 1. You should be able to solve it from there. The answer comes out to be negative 3. So work the rest of that and make sure you get it right. Here I've got a base of 3, so I want 27 to be a base of 3. So this is harder than the rest of the problems we've done on this page, so I'm just going to do one of these. 27 is 3 to the 3rd power, and then I've got the rest of the problem, which is the power of 2x plus 6. So this is kind of crazy. Not really crazy. Now you have to know your exponent rules, which mean to multiply these two exponents. So multiply 3 times 2x and 3 times 6. So I'll get 3 to the 6x plus 18 equals 3 to the 2x. Now I can drop the bases. 6x plus 18 equals 2x. Guys, best way to solve this is just not to subtract 2x from both sides, but to subtract 6x from both sides. So you don't end up with a 0 on one side of the equation. So I'll let you finish it from there. 18 equals negative 4x. Just make sure your answer comes out to be x equals negative 9 over 2, or negative 4.5 if you like decimals. Okay? I'll give you these answers just in case you wanted to try a few more. This one is P equals 10, if you want to try that one. And this one is M equals 7, if you want to try that one. And this one is Y equals 8, if you want to try that one. I would say stick to that and don't do any on the back. If you want to try this one up here, the answer is V equals 4. All right, I'm at 9 minutes, so we're not going to do the warm-up because that's the same thing we just did on the other page. Sometimes it is not possible to find a common base with these exponential equations. So these are the 4 steps. I won't read them to you. You can read them yourself. You say, well, so I can't do 2 to a power. I can't change 61 to a base of 2. So what do I do? I'm going to either one of 2 things. I'm going to draw a line, and I'm going to let you choose which way you want to do it. I can take the log of both sides. Log of 2 to the x power equals log of 61. By the way, that's base 10. And then I bring the x out front here. X times log base 2 equals log 61. And all I do to finish this problem is divide both sides by log of 2. Cross that out. So x equals log of 61 divided by log of 2, which is approximately 5.9307. X is approximately equal to 5.9307. Now, guys, I also think it's just as easy to convert this to logarithmic form. So we just go log base 2 of 61 equals x. To me, that's the easiest way to do this problem. And then I just type log base 2 of 61 into my calculator. And I get the same answer. Again, I'm going to continue to do it the way in red here. So I'm going to do log base 8 of 92 equals m minus 7. Now, all I need to do is calculate this in my calculator, log base 8 of 92, which is approximately 2.1745 equals m minus 7. Now, remember, m's not by itself yet, so just add 7 to both sides. Remember, that's 7.000 whatever. But anyway, so the answer is 9.1745 is approximately equal to m. Okay. Why approximately? Because I had to round off this number when I typed it, when I got it out of my calculator. So again, where it says you can take the log of both sides, you can certainly take the log of both sides right here. It works. In fact, just to show you, now, real quick, don't forget step 1. Sometimes you have to isolate it. This exponential expression right here needs to be isolated, so I have to divide both sides by 4 first. 7 to the n power equals 37. But again, so I'll take the log of both sides now and show you that way, but I still think it's easy, much easier to do it this way. But I can do log of 7 to the n power, that's base 10, equals log of 37, that's base 10. Bring the n out front here. N times log of 7 equals log of 37. Now just divide both sides by log of 7 to get n by itself. N is approximately equal to, type log of 37 divided by log of 7 in your calculator, 1.8556. But again, right here where you took the log of both sides, you could have just converted into logarithmic form like I did over here in red. So this last one I'll do in red again. Got to isolate the expression, so I need to add 5 to both sides first. 4 to the 3w equals 8. Now, I'm not going to take the log of both sides. I'm just going to convert it. Log base 4 of 8 equals 3w. Now all I got to do is divide by 3 on both sides. Type this expression in the calculator. W is approximately equal to, looks like 0.5 or 1/2. And it's not approximately equal to, it's exactly equal to, because this one could be simplified. Guys, and that's it. I'm at 14 minutes and 45 seconds. So the next video is just going to be me going over some odd problems out of the homework. All right.